Hello everybody, we're going to be working on notes for the probability menu. This is worth 1 point in the menu, but you have to take notes over this entire section and then get them okayed by me. Probability is a concept that you use very frequently with things like marbles and coins and dice and cards. It's the chance of something happening. Okay, and all probability is trying to weigh those odds of something happening versus it's not happening, and then making decisions based upon those odds. So if we start with simple probability, there are two concepts: theoretical probability and experimental probability. Theoretical probability is the chance that something should happen in theory. So if you flip a coin, in theory, you should get 50% of the time you should get heads. The reality is that doesn't happen very often, and that's where you go into experimental probability. So if you have a 50% chance of getting heads and you roll a coin 10 times, maybe you get heads 8 times or 2 times. That would be the experimental probability. Frequently, those do not match up in small numbers, but over time, they become much more likely. So when we have a bag of marbles here, and in this bag of marbles we have 3 red and 4 blue, which means that we have 7 total marbles. We want to know the probability of, that's what P means here, P of blue means probability of pulling a blue marble out of a bag with 7 total. Well, the way that we do this is you have your number of chances and you make it a ratio with the total chances. So if we look at the probability of blue, we look here, we have 4 blue out of 7 total, and now we have our ratio. Our probability is 4 out of 7. And if we wanted to know what that was as a percentage, we would roll it here, so that's 57%, because we took this number, we can multiply by 100, and we get about 57%. It's very important that you put about when working with things that are not exact. About 57%. The probability of red, then there are 3 red out of 7 total. So that is about 43%. So that's simple probability. Now this is definitely theoretical probability. If we actually took a bag of marbles and we started pulling them out, it's very unlikely that we would actually hit these percentages exactly. We'd be a little bit off in either direction. Okay? So I want you to try some of these simple probabilities and see how you do, and then I'll go through them. Okay, so for this top one here, rolling an even number on a 6-sided die. Well, if we think about a die, there's 1 through 6, and they have 2, 4, and 6 are even numbers, so there's 3 possibilities out of 6 total numbers. Well, if I took that and simplified it, that'd be the same as 1 out of 2. So that means that I have a half chance of getting an even number, which is equal to 50%. To get an even number on a 6-sided die. Pulling a blue marble out of a bag with 6 blue and 3 red, that means there are 9 total. So the what am I doing? So the probability of blue would be equal to, there are 6 out of 9 total. So that's 2 out of 3, or about 67%. And finally, you shot 18 baskets and made 4. What is the probability to make the next one? Now, this is a little tricky because you have to be weighed under the idea of you continue at that same rate. So if we continued at the same rate, that'd be 4 out of 18 or 2 out of 9. Which is about 22%. But what's tricky about this problem is that it's not actually 22% that you'd make the next one in theory. Now, this is the experimental probability that would make sense, but your shooting percentage is not something that depends on your previous shots. It would actually something that you could rate long before you had done this experiment. So that's what a little bit tricky. You got to be very careful when talking about experimental probability. But I would say the correct answer for this problem right now is about 22%. So now the other thing is when you're doing multiple actions at once. So if we think of flipping a coin, if you flip a coin, it's a 50-50 shot of getting heads each time. But if you are trying to get heads twice in a row or 3 times in a row, the probability for that would go down. So what we are going to do here is find the probability of multiple items, and we are going to do what we call without replacement. So you have to be very careful with this because replacement means that you put the item back after you pull it. So for this, we have 6 $1 bills, we have 8 $10 bills, and 3 $20 bills, which means that we have a total of 17 items. But after we pull one of them, we are not going to put it back. Okay? And basic concept of probability of compound events, it means multiple events. I want you to multiply the individual probabilities together. So the probability of pulling a $20 bill, then a $1 bill. So currently, a $20 bill, we have 3 of them out of 17 items, which is about 18%. So I'm going to put that over here. And then we're going to multiply that times the probability now of pulling a $1 bill. Well, this number has now changed to 2 because we are doing it without replacement. So that means that this number changed to 16. So now we have 6 out of 16, which is 3 out of 8, or 37.5%. Now, each individual probability is 18% and 37.5%, but the probability of them both happening is very, very unlikely comparatively. So that means that the probability should go down, and they do. So if we did 18% times 37%, obviously multiplies a decimal, it's about 7% as the answer, which is very unlikely. That means out of 100 times, this would only happen 7. If we leave it as a decimal, it's 18 over 272, which we could then simplify. Okay? Now, we start over here, and we try the next one. Pulling 2 10s back to back. Well, we have 17 items, and 8 of them are $10 bills. So we have 8 out of 17. But after we pull, we leave that 10 out that we pulled the first time. Therefore, there are only 7 left, and there are only 16 full items left. Now, if we multiply this out and simplified, we would eventually get 7 out of 34. Which is about 20.5%, or 20.6%. Okay? So the probability of pulling 1 $10 bill is about 50%. The probability of pulling 2 back-to-back is about 20%. Well, then pulling a 10 and then a $50 bill, well, something should jump out as pulling a 10 would be an 8 out of 17. But the probability of pulling a 50, well, there are 0 $50 bills out of the 16 remaining bills. So that means that 8 times 0, that's 0 out of 272, which is 0%. And that should jump out at us because there was no $50 bill to begin with. Therefore, there should be a 0% chance of pulling a 50 in anything. Okay? How are we doing on time? About 10 minutes. So, the basic idea here is that you want to take 2 probabilities of the individual items and multiply them together. So what I want you to do is, I want you to bring these problems into me in order to finish your notes. Probability of winning 2 games in a row, probability of losing 2 games in a row, and the probability of winning 4 games in a row. If you bring those into me with the remaining of your notes, you get your 1 point for the menu.